Hello community! Yesterday Qwen published a new AI model and I thought, hey, I have to have a look at this. So here we have brand new research paper WorldPM. It is great. This is May 16, 2025 and they tell us, hey, we have here a new world preference model to emphasize here the scaling potential. And I said, hey, great, because my last video was here neural scaling here for small language model, and now just the very next day we have a new publication by Qwen. Let's have a look. So I went to their GitHub and I looked, oh, what? Just the README from yesterday? 9 stars, and what is happening? And then I said, okay, let's have a look here at Hugging Face. And here we have it, no? Yeah, just look, updated 6 hours ago. We have here WorldPM 72B, and then we have reinforcement learning from UN feedback and ultra feedback. And I said, that's interesting. Let's have a look at this. And then when we look at the WorldPM 72B download, 0. It was published 6 hours ago and it is 0 download. What's happening here? And if you look at the code, yeah, it's available. Auto tokenizer configuration, auto model here from Hugging Face Q1 WorldPM 72B. Get the model, the tokenizer, the conversation, the output, the scores. And I said, hey, wait a minute. Now look here. Now we understand what it is. It is a reward model. It is a brand new reinforcement learning model. This is now fascinating. So what have they come up with? What is new? Let's have a look. Do you remember this? More than 500 years ago, Leonardo da Vinci painted here l'uomo vitruviano, the Vitruvian man. It was about 1490. And you know, at the time, more than 500 years ago, this was the archetypical representative of the high Renaissance. This was the modern man, the modern human, the perfect symbol here of the Renaissance. And you know what? This is exactly what we're going to talk about, because this is now in AI, our WorldPM. And you might say, what are you talking about? Well, it is rather easy, because 500 years ago, this were the perfect proportion. This was the perfect man, if you want. And now we look here at a global reinforcement learning by human feedback. And we also say, hey, what is the perfect human attitude? What is the perfect human thinking, and how should an AI work here if we go here back in time? Because we know what we do here today. We have little domains, and for each little AI LLM, we have a reinforcement learning from human feedback for a domain in subphysics. And we have a reinforcement learning from human feedback for some medical, or some reinforcement learning from human feedback for some social media platform. But now there's this idea, hey, what about we define now here a global new human? A reinforcement learning from human feedback for AI. Absolute fascinating idea. And you know, in AI, we have here our LLMs like a ChatGPT or the Qwen here. And you know, we have to align those AI models because they do not behave right out of the box. So we have here an alignment process to make those AI helpful, harmless, and honest to humans. And OpenAI years ago introduced a methodology they called reinforcement learning from human feedback. And very easy, reinforcement learning from human feedback involves training now a separate AI model. And it is called a reward model. Now, a very specific form of this reward model is called a preference model. Why? Because in good old days, you had humans sitting down and looking here at preferences. A human had an AI-generated output from answer A or answer B. And then the human said, hey, I have a preference for answer A or a preference for answer B. So therefore a preference model, but it is simply a reward model. Now predict which of the two AI-generated responses a human would prefer. And of course, we do this today in a synthetic way. So we have here now a preference model, or a reward model to be more correct, that guides now the LLM, the large language model, in its own alignment to be friendlier, harmless, honest, exactly like humans want the AI to be, to produce better outputs that align with human expectations. So what we have now? We have our LLM that we want to further align here to the expectation of a human. And then we have here the reward model, our AI model, that either you call it a reward model or a preference model, a PM. For me, PM stands for Prime Minister. Yeah, a little bit British, I know. But never mind. So at first you have to train the reward model. No? I'll show you in a minute how we build the architecture for this, but this is rather simple. But think about what it is, what it incorporates, this reward model. It defines here, like the Vitruvian Man from Leonardo da Vinci more than 500 years ago, it defines the human standard, ethical, moral, friendly, honest, true. This is here, if you do not want the humans fill out the preferences that the AI provides here, this is here the AI reward model that is now, if you want, incorporating a transposition of Leonardo da Vinci here to the modern preference model. And now if the language model again says, hey, for a given query, I give an answer A and an answer B, and now we do not have a human sitting down and say, yeah, A is better, but we have now this reward model, and this is so much more cost effective. And then we just go on and we have another answer, and this model says, hey, here B is better, and you get the idea. So this reward model that defines, if you want, the human ethics, the human moral, the human standard, how a human would react to guide the development of our LLM, of a GPT, of a Gemini, of and whatever. And of course, you know, with reinforcement learning by human feedback, if we have the reward model, we can use here reinforcement learning alignment. Let's say we go with GRPO. Standard, no? If you want to learn more about this, especially here the Bradley-Terry model here for a preference-based reward modeling, I would recommend this publication from January of 2025. And if you would like to see, hey, are we really stuck with GRPO? No, we have much better methodologies already. Here are 2 videos here from my channel. Here you can go with LCPO or you go with DAPO, and then we have even VAPO. So the continuation here, we have a fast AI research development going on. So if you want to inform you further. And now this new paper here by Qwen says, we look at the scaling laws. And they say, so what is the ideal size of this human substitute here? Is it a 3 billion free trainable parameter model, a 14B, a 32B? And they came up, and please read their study, it's a beautiful paper. They say, you know, here the perfect equilibrium is a 72 billion free trainable parameter AI model. This gives us here the best result for the reward model for the PM. So if you think about it, this WorldPM now learns to predict which response a human would likely prefer. But at first we have to train this AI model, no? We need training data. But let's start here. The input here, or the output here is a score for each response, and the difference in score indicated the strength of the preference. So we have now, with extending the concept of the scaling laws from the large language model, now to the reward model or to the preference models. And indeed, we find, no, the authors find scaling laws here, not only like in my last video in LLMs, but now also they find similar laws here for the reward model. And I already given you here the result. The 70B model seems to be here the perfect equilibrium. They also said, you know, all LLMs are pre-trained here on vast text corpora here. And now we did the same. The authors also pre-trained now here the reward model, the PMs here, on a vast amount of preference data from public forums. Because how you want to define here the modern man, the modern human, the modern female approach, what is it? Moral, friendly, ethical, true, honest? How you define this for an AI? So they went here to public forums, luckily not to Facebook or anything like this, and they examined here Reddit. Yeah, there's a lot of AI flooding now Reddit. I don't know how many days until Reddit will become unusable, or Quora or Stack Exchange. And they collected here 15 million preference pairs. There's a lot of data collection. And they found, yeah, our PM get consistently better at identifying here deceptive or factually incorrect responses as the training data and the base model size 72B increase. And they say with 72B, significant improvements, while the smaller ones here, they really struggle and they would not recommend here smaller size PM. And they said, you know what? Then we had a pre-trained WorldPM. And now this serves now as a foundation model, absolutely similar here to the LLM. Because this pre-trained WorldPM can now be fine-tuned on smaller, domain-specific, human-annotated preference dataset. Maybe you have this if you have a call center or a financial center or a medical response center or whatever you have, leading to better performance and sample efficiency than training here PM from scratch on just a small data set. They say, so it is beneficial to have a huge pre-trained world reward model. They have a better alignment, especially if you do something like reinforcement learning for human feedback. And this more accurate PM can now guide here the LLM in a much better way to produce here a more aligned output that humans prefer. A better style, a better reception by the human, a better conversation user interface. So it's a win-win situation that they are looking at. So it's interesting for me, because now we had all the time the pre-trained LLMs as foundation models here for autoregressive tasks, predict the next token, various text generation tasks. And now, first time now they say here for Qwen, we want to create this world reward model, which also aims to be the foundation model for the human preference, for the understanding how humans want to communicate with AI and how an AI should be in the interaction with humans. Now, it's very simple, the architecture of a reward model or a preference model here. If you are a subscriber of my channel, you know this, because, what a surprise, we start here with a pre-trained LLM, go with a Qwen, a GPT, whatever you like, and the hidden states at the final layer before the token prediction head. This contains already quite a condensed summary of the input text, this means the prompt and the response. And now how to turn an LLM into a reward model is basic. It's so simple, You just remove the original language modeling head. So this is the part of the LLM that predicts now the next token. And at the end, you simply add a simple head, just a single linear layer, no activation, and it takes the final hidden state or a pooled representation of several hidden states and maps it into a single scalar value. And guess what? This scalar value is our reward score. As easy as that. Yeah, common loss function is, you see here in the research paper that I recommended here some minutes ago, the Bradley-Terry model, but never mind, it's done. But the most important is now data. The data quality, the data amount, the data interaction. And they decided here, they looked at all the different things and said, hey, Stack Exchange is really interesting. I have here Stack Exchange mathematics, you see, where you have your problem, you vote, you have answers, you have views, you can upvote or downvote it, or you go here to personal finance and money, and you see here. So it's really a community platform, but it's not a social media platform where you have all the, let's say, BS of whatever, or Facebook or this nonsense. But this is really something where you say, okay, here are people really interesting to find solution, to present solution, to have a little bit more challenging task. Like here, what about here my 401k amount and what's happening to me financially and so on. So the authors of the study now went really deep and they analyzed here multiple sources. So showed you over the Stack Exchange here, SE, as you see here. Then they looked at Reddit, they looked at Quora, they looked here at Helps Tier 2, and all the different sources here where we have community interaction. So interesting. I think there's maybe a very interesting point. I don't know how active here, for example, European users are on this different platform, or friends from Asia are on this particular platform. And if you just look at, I don't know, at English now, is this really a representative sample of a global reinforcement learning by human feedback? I don't know, but okay, we have to start somewhere. So, okay, I understand exactly what they tried to achieve. They went to a global platform and had a look at this and trained on those. And they now analyzed this and the quality and everything. They said, given Stack Exchange superior quality compared now to other sources, we selected it as the representative forum data source for modeling here the world preference. And I think this is an absolute interesting statement. And I think we should come here together and maybe discuss a little bit more how we can have a common denominator. The American culture, the European culture, Southeast Asia culture. I think there are cultural differences between India and China and Japan and South Korea. So I think we have to talk about this. If we really want to establish this on a global level, there's a lot of work to be done in the future, but never mind. And if you have seen my very last video, you know exactly what I feel if I see now that we have here open source data coming in from all over the world. The security risks are extreme. But never mind, we are pushing further ahead with AI. But just if you want to have a non-good night's sleep, have a look at this video and you will not fall asleep in this night. Okay, benchmark data. They said, okay, we integrate now our WorldPM into our internal reinforcement learning by human feedback pipeline, employing now GRPO as the reinforcement learning optimization algorithm. And they did this here on 272B models, and they used here some in-house benchmarking, of course, absolutely in their cultural background here, with the WorldPM and without the WorldPM, and then with the WorldPM. And they did this in an in-house benchmark and an open source benchmark here with Reinhardt and Bench on Alpaca. And you see here the results, and in bold you see with the WorldPM, the reward model, the preference model, they had all over the place a better performance. Now you might ask, okay, from 91 to 93, but this is already close to 100, so I think it's quite impressive what they achieved, no? Yeah, they GRPO alignment here on QWQ32B, never mind. And they say our findings now indicate that the WorldPM initialization, so if we start with this world reward model, preference model, and then we have some fine-tuning, and then we further do this here on domain-specific human preferences, in total we get a better alignment with the human preferences, and we have an overall improved alignment effectiveness. And this is exactly why we do reinforcement learning. So, real interesting approach, real interesting insights. But talking about insights, I want to show you this, what fascinated me. This is here the gradient norm, and here the training data side and the training loss here. And during the training, they say they observed here a moment of epiphany. Because you see here the training loss, yeah, goes down and down. But look, there's here something happening. Do you see this? And the same here if you look at the gradient norm. And they said, at approximately 12.6 million training samples, we observed a critical transition. A sudden drop in loss, clonk, coincides with a sharp spike here in gradients that quickly subsides. And they have now an interpretation what happened in the training here. And they say, we think that this is a successful transition to a better solution space configuration. So this means that the model has discovered a more general and effective preference representation, an internal representation. It kind of optimized itself here, potentially leading to stronger generalization capabilities across different preference scenarios. This is what I find fascinating if you see in the training data, that it's not just a linear behavior, but there's something that a discontinuity, and suddenly you are here in a new solution space configuration, especially a new representation. This is nice. Okay, as always at the end of my videos, I want to give here the voice to the authors, and I thought this is a very interesting paragraph, and they now themselves, they say, you know, what is the future of the role of reward models? We have integrated this more and more, and thanks to extensive engineering efforts, most objective dimension we care about can be reliably supervised while significantly reducing the dependence on the reward model in general. So what is the future of reward model? They found now this nice interpretation as a foundation model that you can further fine-tune. You get a better performance. But do we need reward model? Do we have better alternatives? Do we have more advanced technology? Absolutely fascinating if you look here at the AI development pipeline just in the next days or weeks. So here we have it. We started here the video where I told you, hey, Qwen published a new AI model they call the new world model, and I have no idea what it is. Now, 15-20 minutes later, we know exactly what it is, why Qwen developed it, how Qwen now implements this here for the next model, and we even had an outlook here at the AI dev pipeline for the next models. If you're interested to subscribe to this channel, I see you in my next videos.